Among tetracarbonyl nickel, tetracyanidonickelate 2 and tetrachloridonickelate 2 complexes, we have to see which are diamagnetic and which are paramagnetic. So to see that, we have to write the electronic configuration of nickel first. So nickel, the atomic number is 28, that's 3d8 4s2. In the first complex, that's nickel tetracarbonyl or tetracarbonyl nickel. So we have the oxidation state of nickel as 0. So we are going to get the configuration like 3d8 4s2. And in the other complexes, that's NiCN4 2 minus and NiCl4 2 minus. In both the cases, nickel, if you are going to find the oxidation state, nickel is in +2 state. So the configuration will be 3d8 4s0. As a result, you can write the outermost electronic configuration, and every time you have to calculate the number of unpaired electrons. The pairing of electron depends on the type of ligand which is approaching. So if it is a strong ligand, that makes the electrons pair up, and if it is a weak ligand, that can't pair up the electrons. So if the weak ligand is present, then most of the times the complex formed will have the unpaired electron, and that would be paramagnetic. Whereas if you have the strong ligands, then in such cases the electrons pair up in the d orbital of the metal. As a result, this would be diamagnetic. So when you compare the strength of the ligands here, there are 3 ligands: carbonyl in the first complex, cyanide in the second complex, and chlorine in the third complex. These two are considered as strong ligands, and this halogen is considered as a weak ligand. So the complex which has the weak ligand will have number of unpaired electrons, so that would be paramagnetic, whereas the one with strong ligands, that would be diamagnetic. So we have that option C, nickel tetracarbonyl and tetracyanidonickelate are diamagnetic, whereas tetrachloridonickelate is paramagnetic.